Welcome to the Binomial Theorem. We're going to work on the Pascal's triangle by Sasha and Dennis. Pascal's triangle is a triangular array of numbers such that the n plus 1th row is the coefficient of the terms of the expansion x plus y to the nth for n equals 0, 1, 2, or 3. Such examples can be seen by expanding the Pascal's triangle. As you will see in one moment, Pascal's triangle can be expanded into a great number of rows and columns, each corresponding to the previous. When writing it out, you can do an equation as seen right there. Eventually, as you continue expanding, you can go to any term and find any term through the use of Pascal's triangle. It is literally unlimited in the amount of terms and the amount of sequences that you can find. The circle of life depends on Pascal's triangle, as you can see it in every daily life through the nature, such as water, through the sky and the trees. And almost all living things depend on this formation of the Pascal's triangle. Therefore, it is very important to not only the sustainability of life, but also the continuation of mathematical theorems. Now, let us work on a problem. Find the probability of hiring 6 men and 2 women. As you know, 6 men plus 2 women would be 8. So therefore you have your equation that you are starting with. Now, we're going to complete the Pascal's triangle and so you find m to the 6f to the 2, or in the m plus f to the 8th row. I hope this makes sense for you. So, as you should have found, you would have found 28 m to the 6th times females to the 2. Now divide the 2, so 28 divided by 256, which 256 is the summation of a plus b to the 8th power. 28 divided by 256, by the way, is your answer. So now let's work on 2 more problems. Start by expanding a plus b to the 7th, and then doing the other one. Did you get the answer? Congratulations, you now know Pascal's triangle. Coming next, the binomial theorem. The binomial theorem is simply another way of expanding the rows of Pascal's triangle, or finding a specific term in a row. Such examples of this can be seen very easily also in daily life, for it is the same sustainability and the same ideas that the Pascal triangle represents, however, simply a different way to find the similar, I don't even know what I'm saying really, but I hope you understand what I'm trying to give. So we're going to use an example of this, of Pascal's triangle, to start off, because you know Pascal's triangle. So start by expanding 5a minus 4b to the 4th power. You should get 5a to the 4th power minus 4 times 5a to the 3rd power times 4b, and then etc., which that will eventually equal 625. A to the 4th power minus 2000 a to the 3b plus etc., as you can see by the video. So obviously, by using Pascal's triangle, you can see this. However, we want to use binomial theorem. Now, nk, which is also can be seen as E, a big huge summation E, is commonly used, but we're going to use nk. We're just going to take out the e, and so that then equals n with an explanation point, so all summation of n, and over n minus k. So the summations of both n minus k, as you can see in the Pascal's triangle, for example, you can find that. However, we're going to do n minus k, big huge thing, and then times k summation. So let's do an example. 52 over 5, we have 52 explanation, 5 explanation, 47 explanation, and that would therefore equal 52 times 51 times 50 times... So then you have 51 times 50 times 49 times 48, which over 5 times 4 times 3 times 2 times 1, and that is therefore going to equal your answer, which is 2,598,000. Excuse me, 2,598,960. So now that we did that together, let's try some following problems yourself. So expand the binomial a minus 6 to the 6th power.
Did your work look something like this? 6 exclamation over 0 exclamation times 6 minus 0 exclamation. You just simply substituted k and n, and you substituted the terms. Then that would be equal times a to the 6th minus 0 and b to the 0. Then you would equal, hopefully your answer should be 1a to the 6th. That would be your finding the first term. If you were finding the next term, you would put instead of 0, 1, 2, 3, etc. So now, hopefully you understand the binomial theorem. Therefore, we're going to work on two more practice problems before we finish. So we're going to find the fourth term of a plus b to the 9th. The work below, you can see 9 over 0. That then is 9 exclamation over 3 exclamation times 9 minus 3 exclamation. And that eventually will equal 84. A to the 6th, b to the 3rd. Hopefully this helped you out. Congratulations, you now understand both the binomial theorem and Pascal's triangle. Thank you very much for listening, and hope you guys have a wonderful day.